So, a very good morning to one and all present here. Myself, Dr. Kanksha Dubey. So, today we'll be talking about a very important topic in organic chemistry, that is amines. Amines are defined as organic compounds that have amino groups in them. So here, as you can see, that clearly it can be defined as organic derivatives of ammonia with one or more alkyl or aryl groups bonded to the nitrogen atom. Now, talking of functional groups which are present here, so as you can see here, nitrogen could be attached to the alkyl and aryl group on the two sides, and it can also be attached, that alkyl group could be hydrogen or hydrocarbon too. Now, talking of classifications of amines, so amines can be classified into three categories, that is primary amines, secondary amines, and tertiary amines. Now, primary amines could be when it is attached by one alkyl or aryl group to the nitrogen atom, while secondary could be two alkyl and aryl groups attached to the nitrogen atom. Tertiary amines could be termed as three alkyl or aryl groups attached to nitrogen atom, whereas in case of quaternary amine, an ion in which nitrogen atom is bonded to four alkyl or aryl groups bears a positive charge. Moving further to the namings of amines, so first we'll start with common names. Here we can see that it is formed by the names of alkyl groups that are attached or bonded to the nitrogen atom and followed by a suffix called amine. And similarly, di, tri, tetra prefixes can be used to indicate the number of substituents which are attached here. See, for example, in the first you see ethyl group is being attached to amino group and therefore we label it as ethylamine. Whereas in case of second, two methyl groups are attached to the nitrogen atom and ethyl group on the left side, therefore we term it as ethyl dimethylamine. And in the third, we term it as tetrabutyl ammonium chloride because butyl group are attached at four positions. Therefore, it is termed as tetrabutyl. Now, talking of IPAC names, so they are done similar to that of alcohols. The longest continuous chain can be used to determine the root name where E of the alkene could be substituted by amines. Now, other substituents are the carbon atom are given numbers and the prefix N is used for each substituent on nitrogen atom. Say, for example, here in first example, we can see that butane group is attached to the amine, so we term it as 2-butanamine because it is attached at second position. Whereas in the second example, we can see that methyl group is attached at the third carbon and butanamine is attached from the first carbon. So we term it as 3-methyl-1-butanamine. Next, the prefix amino is used to indicate the presence of NH2 group in a molecule containing one more than one functional group also. Say, for example, in the first example, amine group is also present and carboxylic acid group is also present. Therefore, in that case, we use prefix amino in front of carboxylic acid. So it is termed as aminoethanoic acid. In case of second example, we can see that amino group is attached to alcoholic group. So we term it as 2-aminoethanol. And similarly for others. Next, if we talk of naming aromatic primary amines, so these are also known as arylamines. Here, basically, amino group is directly attached to the aromatic ring. As you can see, when phenyl group is attached to amino group, it is termed as phenylamine. Now, talking of preparation of amines, so there are several methods for preparation of amine. The first could be reduction of nitrogen-containing compounds, that could be nitro compounds, nitrile amides, and oxide. So here, as you can see, both nitro compounds and nitrile compounds, if treated with lithium aluminum hydride in presence of dry ether and water, could be converted into primary amines. And in case of nitro compounds, it can also be converted to primary amines by treating it with hydrogen and platinum or tin with HCl and NaOH. Next, we have conversion of primary amine for oxyamide. Similarly, it could be treated with lithium aluminum hydride in presence of dry ether and water and can be converted to primary amines. Next, we have alkylation of ammonia. So here you can see that if any haloalkanes could be treated with ammonia, forms alkyl ammonium salt, followed by treatment with sodium hydroxide can be converted to primary amines. Next, we have a very important reaction that is called Hofmann degradation reaction of amides. So here, as you can see, if amide group is treated with sodium hypobromide, that is NaOBr in presence of NaOH and bromine, it could be converted into primary amines. Next, we have few reactions where it is first treated with nitrous acid and gets converted into arene diazonium salt. In presence of different chemical reagents, different arene diazonium salts are formed and treated and can turn into different compounds. Say, for example, if these are treated with fluorofluoric acid, it can form ARF. If it is treated with alcoholic group, that alcoholic group attached to the arene diazonium salt. Therefore, we again have a different reaction called as azocoupling reactions, where a strong electron donor group and two rings gets attached in between with a nitrogen uh, attached with two rings on the other side. This sort of reaction is termed as azocoupling, where two rings come together, forming a nitrogen bond in between, and the compound is termed as azo compound. Next, talking of the physical properties of amines. So here we'll be discussing solubility and boiling point. So first, the boiling point, if we are discussing, so we can see that boiling points of amine usually increases with increase of molecular mass. And low aliphatic amines are usually gases or low liquids. Now, amines are usually polar, so both primary and secondary amine associate by intermolecular hydrogen bonding. I hope you know that there are two types of hydrogen bonding, that is intra and intermolecular hydrogen bonding. So here in case of amines, intermolecular hydrogen bonding takes place. Moving further, comparing the boiling points between primary, secondary, and tertiary amines. So for isomeric amines, the boiling point decreases in order from primary to tertiary. And this decrease is basically due to intermolecular hydrogen bonding. Again, talking of comparing the boiling points with other organic acids or compounds. So we can see that here boiling points of aliphatic amines are usually higher than alkanes and lower than alcohol or acid. The reason is NH bond is more polar than CH bond, but less polar than OH bond. So here below, if you can see that the boiling points of amines are higher than those of alkenes, ether, and ethyl halides, whereas lower than ketone, aldehyde, alcohol, or acid group. Now, talking of solubilities, all three classes of aliphatic amines are capable of forming hydrogen bonds with water molecules. So, the lower amines are very soluble in water because they can form hydrogen bonds with water molecule easily. The solubilities of amine usually decreases with increasing number of carbon atoms and chains, but they are usually soluble in organic solvents. Now, talking of basicity of amines, so amines can act both as a nucleophile or a Lewis base or a Bronsted-Lowry base. Now, if it acts as a nucleophile, it's because it has lone pair of electrons, which can be easily donated to the electrophile and forms a carbocation. Whereas if in case of a Bronsted-Lowry base, it will easily accept the proton from the proton acid. So here we can say that amines are fairly strong base and their aqueous solutions are also basic. Amines can abstract proton from water, giving ammonium ion and hydroxide ion. Now, if we talk of writing the equilibrium constant here, so here the equilibrium constant indicates pKb as minus log base 10 kb. Therefore, it can be indicated that strong bases have small pK values. Now, next, we'll be discussing more of the contents here in the later classes. Thank you and have a nice day.